Welcome back. We are discussing statistics for data science. So, in the last video, we've seen the theoretical part of mean, mode, median. Now, let just a little bit with the number, we'll see what is mean, mode, and median. So, mean, what is the important part is we have to find the average, but what kind of data? The data that is closely related. Okay. So, let's consider your data something like this. So let's give a random information. Okay, so we've got some 15 rows. And if you check this information, so what is the minimum point here? It is 2. And the maximum point is 12. So here the minimum point is 2 and the maximum is 12. So here we can understand that we are dealing with the closely related data. Okay, so when you have such a data, you can directly calculate the average of the data. Okay, mean of the data for central tendency. So we are discussing about central tendency. Again, what is central tendency? The data, the point that describes your entire information. Okay, that one point will give you a good picture about your data. So here the average of 5.8. So average of this data is 5.8. So why are we calculating average? Because they are closely related information. Okay. So let's say another type of data. So mode. So again, let's use the random information like, so let's say for an example, for calculating the temperature of a city from Jammu and Kashmir, let's say. So if you take the temperature, it will be frequently, it may show a certain type of temperature like again and again. Okay, rarely you're gonna get 5, but mostly it's 2 degrees Celsius. Okay, so in this type of data, how will you represent? Okay, so on an average, or we can say mode is 2. Mode of this data is 2. So central tendency measurement of this type of data is 2 because it frequently it's occurring again and again. Okay, the most frequent occurred data is your central tendency of this type of data. So what about the median? Okay, so here is where this median plays major role, because practical data, if you see, it has very huge noise. Okay, it's not very clean information, and you will have a lot of noise in your data. Okay, for an example, if you have collected the car prices of India, so you see the car prices starts from 2 lakh and it goes up to, let's say, 50, 60 lakh, even 1 crore. Okay, so let's say 2 crore, 2 lakh, 5 lakh, 6 lakh car. So you've collected the car prices of India. Okay, and one car is 50 lakh and then another car is 80 lakh. Okay, so if you see this data, minimum point of this data is, but see the maximum point of this data, it's 80. Okay, so we call this as an outlier. Okay, this part, this one particular data that is off points are called as an outlier. So if you have such an information, how will you represent your data? Okay, so for this, what we have to do, we have to first arrange your data in your according to like small, either from the smallest to largest or largest to small. Anything is okay, but arrange your information and take the center point of the data. So how many data I do have? I like see around 14 rows, and in this in between. Okay, so if you have 2 points, then take average of 2 points. If you have just 1 point, then take that 1 point. Okay, so here the measure of central tendency of this type of data is 7. Okay, so median of this data is 7. So uh, again a quick discussion on why are we even taking the center point. Okay, so when we plot the graph, let's consider like a student graph. Okay, so you have collected all the 10 standard students and their marks, and you're trying to plot it. So plot like a histogram. So here it will be like a mark. Okay, this side and this side, number of students who have taken that particular mark. Okay, so if you see, mark starts from what, like basically starts from 0 till 100. Okay, so start again. So start plotting 30 mark. So students who have got 30 mark, let's say 100 students have got 30 mark. So your plot will be here. Okay, this is 30. Okay, and then so this is your point. Then let's say, for example, if you keep increasing 50 to 50 mark, you slightly see the increase in your number of students who have scored 50. Okay, and then you see that 60, 70, you will see that number of students who are scoring 70 marks, because that's the average mark usually will be scored by all of the most of the students. Okay, and then when you see the higher marks, okay, this side mark will increase, right? So if you see students who are securing little higher mark, like let's say 8, 80, 90, and these are again higher end, so you will start seeing the decrease in the number of students. Okay, you will not see lot of students who are scoring 90, 99. Okay, very rare, very few exceptionally good students, correct? So when you plot this type of data, you will usually get a curve. We call this as a normal distribution. Okay, and when you plot it like this, and when you draw the middle point, okay, again you have to think, why are we taking this middle point? Why? Because this is where the concentration, okay, many students have scored in this range. Okay, so very 25% will score less marks, and 25 other will score very high, exceptionally higher marks. Okay, let's say 30, 35. Okay, this is the lower end. Okay, and this is the upper fence, correct? So very few will score upper mark, the higher range mark. So we cannot take anything from here. We cannot even consider using 90 mark into our average. So let's consider your 80 lakh car and you try to calculate the average will be little higher. Okay, so let's say for an example, if you take average of this number, then average is 15. Okay, but actually, are you representing, or the 15 is what your representative point? No. Okay, it is, let's say, the mark like 70. Okay, here 7 lakh car would be your representative data, a representative point. But since you have given, since you have added the higher end point into your data, if you try to calculate the average, your average shifts dramatically. Okay, which may mislead, or the conclusion, whatever you're trying to find, it will be a misleading information. So median is used for the data which is irregular in nature, and which is having outliers, or which is not closely related. Okay, this type of data is closely related, and this is not. Okay, in this case you will use median. Okay, so that's it for today's class, and tomorrow and next class we will see the other descriptive statistics.